Today on Still to Be Determined, we're talking about solid-state batteries, what they actually are, why the definitions are such a mess, and why the company I sat down with is going after your phone and smartwatch instead of EVs like everybody else. Welcome, everybody, to Still to Be Determined. This is the follow-up podcast to Undecided with Matt Farrell, where we take a look at emerging tech and we do some deep dive conversations. And today is one of those deep dives. But as you probably noticed, there's no Sean today. My brother's traveling in Europe and wasn't willing to record the show on the road from his hotel room for some reason. Slacker. Anyway, I'm talking with Jorge Diaz Schneider, the CEO of Ion Storage Systems. They're based in Maryland. They're about 50 people strong, and they've built an anode-less ceramic-based battery. It doesn't swell, and it doesn't need any pressure to work, which, if you follow the space, is a really big deal. We get into how their technology actually works, why they're betting on consumer electronics before EVs, and the new continuous manufacturing line that they just fired up. And one of my favorite parts, a really honest conversation about why so many solid-state startups have overpromised and burned out, and the hero cell trap that the whole industry keeps falling into. Jorge had some great analogies too, which mostly involve food, so fair warning, you might get a little hungry. So on now to my conversation with Jorge Diaz Schneider of Ion Storage Systems. So Jorge, thank you so much for joining me today. Before we get talking, we got to address something. I knew the battery industry was kind of a cutthroat business, but I didn't realize that you guys were actually throwing punches at each other. Like, what?
It was literal.
What happened?
Yeah, no, I appreciate the opening. I'm delighted to be here, Matt. Thank you for having us and for the interest. To stay relevant with my 12-year-old middle schooler, I decided to take up jiu-jitsu. Clearly, I'm still getting better at it. But as a function of that, 2 days ago, let's just say things got pretty interesting. And so, in fact, the crowd that I train with gets a kick out of it and said, hey, if you're doing a live podcast, make sure you wear your gi to the interview was one of the recommendations. But anyway, not related to the industry, although certainly it is a tough industry to be in and one that I think makes us stronger just by virtue of constantly demanding better and better solutions. But yes, that's what all this is about.
Well, before we get into what Ion is doing with your solid-state battery technology, I want to talk about you just for a split second, because in my research about you, I had read that you wrote in your Maryland Senate testimony that Maryland has been the central to my journey from a young age, and that America is the land of opportunity, but for me, the state is the cradle. Can you explain how like a kid from Guatemala ends up calling Maryland a
Absolutely.
cradle?
Yeah, I appreciate you doing your homework. The story goes back to the 90s. My father is an MD, and he was a Fulbright scholar, and he was part of the Hubert Humphrey program in Hopkins, and he was studying for his Master's of Public Health back in the 90s. So I was very young at the time. Both dad and mom were always, very much looking for better opportunities for us and very much ahead. So they were always on top of make sure you learn English, stay in touch with trends that are bigger than kind of where I grew up in, which is in Central America. And so my dad ended up pursuing a master's in public health in Hopkins, and I was able to join him for a period of that time. And then later he did a postdoc, and I was able to join him for a period of that time. And so there was always this lure of Maryland and the opportunities that it offered. And it's a state that for me has always opened a lot of doors. I was able to study aerospace engineering for a semester at the University of Maryland. It was always just very welcoming and a very much a, hey, if you can dream it, you can build it. And so that is where that statement to the Maryland legislature came from. It was full circle for me.
And that is where Ion is based, and that's where you've got
Correct.
your first pilot facility?
Yes, exactly. So afterwards, back in 2007, I ended up attending business school. So I moved to the U.S. for my master's here in Maryland, just down the road. And so when the opportunity came about and I read the address, it is right down Baltimore Avenue, right? So it was, in fact, the place that I used to rent when I was a student is very close to the facility. And so it was pretty much a full circle. Again, but all roads lead back to Maryland, apparently.
Also, your journey as your professional career, you've worked at some very large companies. I mean, you've worked at Lord, then Parker. Was it Albemarle?
Albemarle Corporation, the lithium company.
Yeah, that's a massive lithium supplier to the industry. So what was it that made you go from that to a smaller, I think you're like, 75 people sized business?
About 50 now. Yes, we're about 50 strong. The careers that I had always had me in growth segments. When I was with Parker Lord, pursuing e-mobility solutions and from a materials perspective, and helping them develop that business with a lot of that entrepreneurial spirit. That's how it was characterized at the time. And then later in Albemarle, helping build upstream supply chains for next generation solid batteries. It was all startup. And there was always a very special kind of energy that I walked out of every time I would visit potential customers or partners. That it was just this complete can-do attitude. Take on a very special, powerful challenge. And it was something that I would just realize that I would absorb and bring back to my team at Albemarle. And so there was always that allure of an industry with that kind of mindset and being part of it. And so when the opportunity to come to ION came about, that was certainly one of the things that was front and center for it. And the second was the technology itself. It was a lot of opportunities to make something very big very quickly and without some of the headaches that we see in some of the other alternatives. So that's a little
Right.
bit of the background there.
And for your time being at ION, is there anything about the technology that you still find surprising or that you didn't expect going in?
Yeah. I mean, if you would have asked me, a year ago, what our lead adopter or the application where a battery would go into would be, I wouldn't have been able to describe it. So one of the things that you have a plan, you go after a target set of segment, and then organically the market responds to just the innate value of the technology. And so that has taught me to just always be open to surprises, because in the world of batteries and in the world where we're going, where devices are going to continue to command just a different level of performance,
Hmm.
oftentimes the things you take for granted or you overlook the most becomes the most critical ingredient in what some customers are looking to unlock. And so for us, it was high temperature resistivity, it was high temperature resistance. So those kinds of things that we say, well, it's a ceramic, so yes, the cell is gonna behave well in high temperatures, but we need to get higher energy density. Okay, that was an interesting thesis, but here's the market saying, actually, the energy density is more than good enough. This whole temperature thing and the fact that your cell doesn't swell or that it doesn't require pressure is a lot more important to me than that aspect of it. And so what that has taught me is to just always keep an open eye and really an open mind to what this technology is capable of unlocking.
So let's back up a second because, like, what you guys are doing, there's some similarities, some rough similarities to like QuantumScape in
Mhm.
some of your approach. But like you just brought it up right there, there's no swelling for your battery. So could you kind of like walk through how your battery works and what makes it different from the
Absolutely.
competition?
I'll use cookies as an analogy. And so it is all ceramic based. It is anode-less technology, similar to the technical approach of companies like QuantumScape. So what makes it different is basically, but this is a 3D rendering. Obviously, this is at the micron scale. But what our
Mhm.
technology has is a dense layer, which acts as a separator. That's this thick part here. And then you have this kind of porous layer, which, like I said, looks like a Rice Krispie treat. So what
Right.
that does is these cavities are where the lithium plates and deplates. And so what that allows you to do is to have a cell that does not swell and does not require pressure. And that's the key difference. The dual layer and the nature of the porous layer is what makes our approach have those features.
Multiple of your competitors have that swelling. I don't want to call it an issue, but an engineering challenge
There is an
around
engineering
the
challenge there.
swelling. Yeah.
Yeah, it's interesting that you mention it too, because one of the things that we do consider is we consider our approach to be complementary to the industry, so
Mhm.
not necessarily competitive. And so when you think about the challenge that is to make a solid state battery, it's all sorts of things, and you're trying to make quite literally a better battery. This is an anode that has the potential to make any battery better. And so we don't necessarily see those as competitors. We see them as potential cell architectures that could adopt
Mhm.
our anode technology and, by virtue of its unique features, make batteries that do not swell and do not require pressure.
The aspect of the pressure is also interesting because it's like I know QuantumScape has bragged about how like they require far less pressure than some of the other people, and then here you are coming in saying we don't need it at all. It's fascinating that you've got a solid state technology that doesn't need it because my understanding is the pressure is needed because to make the contact for the separator and the cathode.
Choose your
Yeah.
flavor, right? But at the end of the day, these compression plates are there to help the cycling process. In some
Right.
cases, it is, yes, to make the materials come closer together. In others, it is you basically that lithium that is plating that's causing the cell to breathe. has to be kind of pushed back into the cathode, for lack of a better term. And so that's where where that pressure is needed. And so what becomes interesting is if you think of a solid state battery that looks like this, it's natural to think of the application being an EV, right? Because when you have a battery pack the size of a mattress, you can make adjustments to accommodate this massive hardware additions to the technology.
Right.
The approach that ION is taking, and what's been very exciting, is that now you can think about a solid state battery that can fit into, say, a consumer electronic device, for example. Whereas something that looks like this is going to have a tougher time getting to those kinds of markets quicker.
In one of your more recent press releases, I think it was in March, you mentioned a customer has gone through qualification with a customer. Can you give a hint as to what sector they might be in, or
Yeah.
like what the use case might be?
We can certainly give a hint. So what the technology does is it unlocks a different type of sensing capabilities for manufacturing processes that are associated, it's probably as close as I can say, with things like data centers and those kinds of growth metrics and megatrends. And so what you have is a sensor that the current technology is limited by virtue of not having a battery incorporated in it at all. And the reason we are careful is because obviously these technologies are new. So it speaks to the battery being an enabler. Again, the last decade has been how do we make batteries cheaper and how do we put them into other applications? It's been a while since the battery has enabled a segment. It's been a while since the Sony camcorder in the 80s and the 90s, right? That's because that was an entirely new segment. And so we're seeing that with the adoption of our technology, and that makes it pretty exciting.
Let's go down that path for a second, because I know one of the things, again, that sets you guys apart is every other solid state company is basically saying EVs, EVs, EVs. Like they're partnering with BMW or they're partnering with Volkswagen or pick your brand. They're all kind of going in the EV market. And you guys are coming out and you're going consumer electronics is kind of seems to be where you guys are focused first.
Correct.
I love that different take, because I know there's so many consumers out there that look at their cell phones or their smartwatches and wish it had more energy density, lasted longer, and solid state could answer that question. What made you kind of go veer left when everybody else is going right? Like what made you go the different direction?
We saw in our technology the potential because of that lack of swelling and pressure. And we also saw a path that is more conducive to having a better adoption path. So it's less capital intensive. You're targeting applications that generally have a higher dollar per kilowatt hour target. And what you're also doing is you're doing exactly what lithium batteries did in the EV space. You're not just developing economies of scale at a higher price point, because obviously EV will continue to be the destination, but not the starting point. But you're also de-risking the technology. When the technology goes into the vehicle, it would have been in consumer electronics for multiple years. And so it is naturally de-risked in the eyes of the consumer and in the eyes of the EV OEM. For a solid state battery going straight into an EV, that period has to be absorbed by the EV OEM. That's why you see concept cars. It's basically them testing it, and it's them getting data as to how the technology behaves in their specific platform. And what we believe is there's just a lot of potential to basically start in unlocking new applications, building gradually those economies of scale, to then by the time we arrive at the EV stage, now it is not just de-risk technically, but you also have a different cost position by virtue of the journey. And so that was the genesis of it. Now it's not new, as I was saying before. It's basically looking at history. And the reason I believe the approach has not been pursued necessarily before is because of that technical limitation of battery swelling or requiring pressure. And so that's what we seized on.
Yeah, I find it funny they brought up the Sony camcorder, because I had a question for you around that of like this Sony camcorder and that era is what helped to like springboard lithium ion kind of into the mainstream. What do you think the product or device is going to be that kind of springboards solid state batteries into the mainstream?
Yeah. Excellent question. That's where consumer electronics to me is a pretty exciting space. What is a consumer electronics, right? It is your smartwatch, it is your computer, it is your phone, it is your VR headset. There's all these different applications. And the part that gets me excited is that there is going to be a continuous need for better batteries in the space as we bring AI more to front and center. Literally, we put it to our face and we interact with the world through these very different technologies. It is definitely going to be, in my view, an exciting space to watch because in the conversations that we have with these customers, you see the light bulb go off of wait a minute, now I have a battery that can allow me to do blank. And that's where, if I can speculate, it is definitely going to be associated with that trend. And it is going to be a device that hasn't even been able to be conceived just because right now we're accommodating swelling, we're accommodating lower energy densities. And we got used to now being paranoid about whether you put your cell phone on your carry-on and you left it in the overhead, right? Because now they say, well, if you have your battery bank up there, you have to make sure that you have it in your hand because now it's
Yeah.
gotten, progressively worse, right? That's the part that to me makes it exciting.
Yeah. To kind of back up to the technology again, around safety, one of the big selling points around solid state batteries is they're not going to burst into flames. Like you wouldn't have to worry about it being in your checked luggage because it's going to be completely safe. And you in your battery talk about how there's no flammable liquid electrolytes in the battery. But
Correct.
my understanding is there is still a non-flammable liquid as a catholyte on the cathode side, which is somewhat similar to what QuantumScape is doing, if I remember correctly. Is that the case for you as well?
The electrolyte, you characterized it perfectly. The electrolyte is non-flammable. The industry has, I was at one of the conferences in one of the solid state battery conferences in Chicago, characterized it well. I want to say maybe 3-4 years ago. It was the ASSB, All Solid State Battery Conference. And I can't remember who was an industry expert at the time. I have to look it up. Stood up there and says, I think we need to be a lot more gentle with the A. It's almost solid state battery conference because when you think about it, there's all these different permutations that people are looking to basically make the technology work. So, it is a solid separator. So by the definition, that's solid separator and an anode solution. But yes, you're absolutely right. The electrolyte is liquid and non-flammable. So you can think of it as a hybrid architecture that allows you to bring the benefits of what the technology is promising from a safety perspective without necessarily taking longer to develop a fully solid state solution.
There are some people that are absolutists on this with
Yes.
if it has any kind of liquid in there, it's not solid state because a solid state is all solid state or nothing. You've got companies, there's been a slew of Chinese companies over the past few years that have been putting out batteries that are labeled as solid state, but are semi-solid state or quasi-solid state. And then it's all this squishy range because these terms are not industry standard, like calling yourself quasi or semi. It's not an official term. It's kind of this weird area we're in. So I know there's a lot of debate around this. And recently, I think China put out a law and they're putting out a new standard for how to test for solid state. I don't know if you've been following that, where they're going to have this testing protocol to determine if you qualify or not. Do you think that the industry needs that standardized protocol and understanding so that we can all just kind of agree with it of what solid state is and just move on?
I think it's interesting. My view is decisively more pragmatic, right? If you begin with the end in mind, right? Again, to your point, if the end is to be purist in definition, then there's a place for making sure that your starting point must be limit yourself only to solid, 100% solid architectures. When the approach is far more pragmatic, when you start to see that every architecture has a different aspect of it that makes it unique in value, and you start saying, okay, well, let's not start with those initial conditions. Let's say it is a next generation battery. And in this case, what can it unlock at the application level? That to me is a much more palatable approach because it is beginning with the end in mind. It is starting with what the application requires and what is going to be front and center for value for the end user. And so that's why it's also important to just be direct and be genuine, right? Call your approach what it is, make the disclaimer, say, hey, yeah, it is a liquid electrolyte. It is a next generation battery. When you're talking to investors, when you're talking at conferences, you have to always try to straddle and make sure that you're being genuine about the representation of the technology, but realize that, unfortunately or fortunately, there are these definitions. And to me, as long as you're being genuine about what's in it and you're not, trying to represent something for something that it isn't, eventually we'll get to a little bit of a more clarity on what the standard means, right? And I think it'll be motivated
Yeah.
by the application.
My personal take is it doesn't matter whether it's semi-solid state, quasi-solid state, all solid state. If it does what it says on the tin, it doesn't matter if there's a gel in there or liquid in there, as long as it won't catch on fire, it's safer, it lasts longer. If it does what it's claimed to do, that's the most important part.
Right.
And
Application
kind of
driven.
arguing
right?
over a liquid electrolyte seems
Exactly.
silly to me.
Yeah. Application driven tests and standards, right? That's ultimately what we're shooting for.
Batteries are notoriously kind of complex and capital intensive to scale. And I know with your facility in Baltimore, that's your pilot facility. What's the long-term play, do you think, for Ion? Are you going to keep scaling in that direction of doing it yourself, like vertical integration, or are you going to license kind of the ceramic out and let partners handle the cell manufacturing?
It's definitely a scaled approach. This is a technology that requires just a lot of connectivity when it comes to licensing. It's not something you can just throw over the wall and say, here, adopt it. The part that gets us exciting about our scaling plan, we need to focus on making more of the anode. We need to focus on making the ceramic into a component. Looks a little bit like this, that you can basically deploy as a drop-in solution to any existing lithium battery facilities, because that's what's going to make us capital light. The assets to stack a pouch or a prismatic cell are already out there. And in fact, they're competing against technology on cost, right? They're competing against the installed bases in Asia and China particularly. What's exciting about the technology is now you can unlock, by a drop-in solution, you can unlock a battery that, again, doesn't swell and doesn't require pressure using the same asset from the moment you stack the cell onward. And so what that requires, though, is we have to scale to make more of the ceramic. We have to scale to make more of this beyond Beltsville. Now, of course, is less capital intensive than building gigafactories, but it is the exciting next step that we're taking as a company.
Right. So the key technology is the ceramic separator that you guys have.
That's exactly right. Yep.
Okay. And I know that making that ceramic, I had been reading about how like the sintering process is power intensive. It's very difficult. And you have a new sintering. What's it called? Atlas?
Atlas. Yes.
Yeah.
Atlas. What was the term that the team used? Atlas. The Atlas Awakening was about 2 weeks ago. So because of there were just these really cool pictures around how the evolution of the installation and the commissioning and all of it. And so it was I appreciated the team's creativity in latching onto the Titan is now awake, I guess, to follow the full Greek mythology connection. But no, it was really the missing link. When you looked at the technology, from a TRL perspective, there was pretty much a lot of the data points that are required for a technical readiness level were there. From a manufacturing readiness level, having a batch process to make the ceramic was simply a non-starter. And so we took the decisive step end of 2024 to invest in a continuous unit. It is our now pride and joy, and please consider this an invitation to come check it out in person. But yeah, so that is what has allowed us, right? Because when you show up to a customer, you need to show up with a solution, and by a solution, it has to be an anode that works, a cell that works, and you have to have a de-risked view of what that process is going to look like. And that is what was needed. And so a lot of the momentum that we're getting is, okay, I get it now. You do have the ability to make it continuously. Yes, you're going to start with yields low yields as you get the ground under your feet. But it's a very exciting time for the company because the anodes are now going to be made through a continuous process as opposed to a batch sintering process.
Yeah, could we back up for a split second for people who aren't familiar of like what is the sintering process? Like what is it?
It's basically cooking the ceramic. So like I said, the best analogy is baking. And so what you make when you make our ceramic is you basically come up with a sheet that looks pretty much like a wonton sheet, the ones that you put in to make wonton soup. So it's kind of somewhat flexible. And then what you do is you put it in an oven. The sintering unit is an oven. Now the term sintering is important, and as Greg, our CTO, explains it, it's kind of what happens with ice when you put ice in a glass and then you kind of leave it outside for a little bit. if you think about it, the pieces of ice became one single body of ice, but you didn't refreeze the ice. It was just outside. And so it fuses into a single body. That's why it's not just an oven, it's a sintering process, because what you're doing is you're basically being very careful with how that baking of the sheet is occurring through different stages and different process variables to arrive at a piece that is both a solid and a porous layer, but it's really one single piece of ceramic. And that's what sintering means.
Yeah. And Atlas is allowing you to do that in a continuous cycle.
In a continuous fashion. You
to
can
never
think
stop.
of the right word is the green body. So the uncooked ceramic is the green body. That goes in on one end of the furnace. And on the other end of the furnace comes the ceramic ready to be assembled into an anode.
And all your analogies are making me very hungry.
Well, I will say, when I shared with the team the first time, oh, so we're going to get a pizza oven. Everybody was like, no, it's a lot more complicated than that. And so I was quickly corrected. But no, so our process, high level, and again, the cooking analogy is great. The baking analogy is great. You have to start with the right powders. And that is something that we do at scale already through partner relationships that we have. And then we take that powder, we make the green body, and then we put the green body through the sintering process. And so that is at the end what the part that we're going to be focusing on scaling. Our know-how is in the sintering and bits and pieces of the other processes. And through the partnerships that we have a lot of confidence in our upstream material supply chain, which is also important, because you don't want to be making something without having the backbone of a strong supply chain on the back end.
This kind of ties back to what we just talked about a minute ago, but like 5 years from now, your Beltsville facility, is it going to be a permanent flagship, or is it going to be more of a pilot line that proves out future generations? Eventually, just an R&D once it kind of like partners gets scaled up. How do you kind of view this, or is it too early to tell at this point?
I think Beltsville is going to continue to be the center of excellence. The technology, it continues to evolve. There's a lot of projects that are already in flight when it comes to both process design, material innovation, cost synergies, all those things. That is going to be continually be housed here in Beltsville. We have a fantastic team of people. And the facility is quite unique because you're integrating the pilot line with our R&D lab, with all of our different, kind of production units at this point, pilot line production units. So I definitely see that as being core to our strategy and what makes us unique. As we scale, right, these anode facilities that we're envisioning have to be closer to the customer by definition. And so that is where a lot of the effort centers now around understanding what those requirements are and what makes the capital investment more attractive. So you can think of it as a hub and spoke, right? You have the center of excellence here in Beltsville, and then you're developing those capabilities closer to your customer.
And a little more forward-looking as well. I talked about this with Robert at CES a bit, but your current batteries, like watt hours per liter, watt hours per kilogram, it seems to be like right now, it's like at the very high end of what like a standard lithium-ion battery could do at the moment. But there's definitely a projected path for where you guys are going to go. Could you kind of walk through like what it's capable of today and where you think it's going to be 5 years from now?
Yeah, the capability today is, I would say, in the range of what a current lithium battery can do. And I'm talking only energy density, right? So if you look at volumetric or gravimetric energy density, the path is to increase that energy density. And the way you do that, and the reason I like the technology is it sounds easy. It is not, but it is less complex than trying to solve for it using the entirety of the components of the battery. Because what you're trying to do is, again, in this body of ceramic, what you're trying to do is you're trying to optimize the amount of free space in the porous layer to match the amount of lithium that's on your cathode. That's it. If you make it too thick, you're going to have extra ceramic, which is going to make the battery heavy, and you're going to have too much space for the lithium to plate. If you make it too thin, you're going to have excess lithium on the cathode, and you're not going to cycle that. You're going to have dead lithium on your cathode. So the roadmap for increasing energy density is pretty well defined. That doesn't make it easy, but it is pretty well defined. And so that's the part that makes it exciting, because the milestones are going to be continued improvements on a solid foundation that started with our cornerstone prototypes.
This kind of goes back to your experience before Ion as well. But over the time of your career, there have been countless numbers of solid state battery startups that have started and failed and made huge claims and failed. And the industry has been kind of like awash with a lot of companies coming out
Yeah.
with big claims. What do you think most of those failures got wrong? And what do you wish someone had told the field like 5 years ago so that a lot of that could have been avoided?
It's an excellent question. Um, Hindsight, right? I
Yeah.
think capital intensity was overlooked. I think the economics that are required for building gigafactories are pretty intense because it's not just the gigafactory, right? It's everything that feeds it and everything that feeds from it. And so those are investments that are multi-year, that are very expensive, and that require the economics on the back end to support them and pay for them, right? So I would say definitely capital intensity and just capital budgeting in general, how long these things take,
Hmm.
is one thing that probably should have been highlighted a little bit more front and center. Greg has a concept called the hero cell. So like hero as in Superman or Batman, right?
Yeah.
And I really like the concept because there are claims, and in my view, claims should have a population of data. There should be data behind it to the point where it's a significant sample. Stats 101, right? You need to be able to say, okay, we're at 1,000 cycles. Why? Because we have this many cells that have done it over these many cells that we've built, right? Like data. Making claims on hero cells can be dangerous because hero cells are by definition outliers. And they're, you're going to choose the best one of the best batch of the best run that you did, and so you're kind of slicing the universe into the upper end of your curve, and making claims on that, at least for me mentally, makes me make unwanted correlations with, oh, you figured it out. If the battery is at 1,000 cycles, it's because you can make multiple batteries that are 1,000 cycles. And so I think that's probably the biggest learning is just disclose it. This is our hero cell. Look at it. Here's our population. Here's what we're driving towards. Here's what a little bit of that could have probably gone a long way. But look, I can't I can't necessarily lay blame because it's exciting, man. I mean, every time you see one of these cells hit one of these benchmarks, I mean, you just go out and you tell it to the world. So again, it's one of the things that for us, it's we always have to keep ourselves in check to say, okay, wait, before you go tell it to the world, let's look at the data is something that we hold very, very close as a value of the company, that when we go out and we say that a cell is going to do something, we're going to stand behind it. And that's been at the core of the receptivity of the customers that have sampled our technology. Oh yeah, look at it, it's getting to 1,000 cycles. It's part of what we think is behind our success and what's going to continue to carry us forward.
It sounds like you're basically saying, don't oversell it, follow the data, and be transparent. So
Yes,
that transparency and honesty
that's right.
will kind of keep things moving forward.
That's right.
You got giant companies like CATL saying that solid state is just not economically viable. And I get why they're kind of saying that because they're pushing
Yeah.
all in on sodium ion and these other technologies. So I kind of understand why they're saying things like that. QuantumScape's pilot is running. Toyota keeps pushing out their timelines. Donut Labs, we talked about before I hit record, they've made some wild claims at CES, and there's a lot of question marks about them. Where on the credibility spectrum do you see solid state actually sitting right now in 2026? And where do you think it's going to be by like 2028?
I think we are going to see solid state batteries continue to make their way to our lives. You already see it in a very small scale, like the tiny ones that go on boards and satellite type opportunities. I think solid state is definitely a technology that is viable, and that by virtue of that adoption, we're going to see more of. From a readiness perspective, the more flexible the technology is and the more it can use existing assets, the better the adoption is going to be. And that's where we firmly believe that we have something that is pretty unique, in that it is flexible and it can adapt into the existing assets that are currently making batteries. Every technology, when you look at it, has something unique and special. And so I firmly believe that there will be a space. How large the space is going to be, we will see. But every technology, by virtue of its unique aspect, is going to have a place in 5 years' time. You have the sulfidics, you have the polymerics, you have the oxidics, you have all these lithium metal anodes, you have And everybody, if you look at the core technology, everybody has a baseline and a spike of what they do pretty stellarly. And so it's, like I said, exciting to be a solution that could potentially enable those things to come to market sooner. Because when you're on the anode side, you're helping everybody take care of the swelling and pressure issue. And so
Yeah.
I'm pretty excited about what that can look like.
So it sounds like you're basically saying there is no one battery to rule them all. It's not Lord of the Rings here. It's going to be little niche players, people filling gaps based on the strengths of their cells,
Yeah,
kind of filling the market.
correct. And I also think it is going to be driven by, like I said, by the application, by the end user. Because back to your point around why is this so long why is it taking so long by the existing batteries? Economically, right, you're always going to be biased towards maximizing your existing assets and maybe making incremental innovations on your same platform. But that's how you remain profitable, right? In a cost leadership position, a disruption must come from the market, must come from somebody willing to pay for it. And so that's a little bit of why putting it in the customer's hands was key to our strategy. Basically saying, well, we're going to go to the consumer electronic OEM, we're going to go to the EV OEM, we're going to go to, so that they see the value, they can see a future for the tech, and then it creates this pull-through effect in the supply chain to say, this is the technology that I want. Because now you're not alone. You're not
Yeah.
pushing a string with the cell manufacturers. You actually have a need on the other
Yeah.
end that completes the equation.
Okay. So for a year from now, what's the headline that you hope is written about Ion? And what's the headline you're most worried about?
Fantastic question. Um, I think the headline that I get most excited about is the confirmation of adoption, right? Hey, you've reached critical scale. Like momentum is here. The question has been answered. Click on this QR code and order your solid state battery, right? Like that.
Yeah.
That that's pretty spectacular. The part that worries me the most is probably having one of my kids have an accident that's related to a battery failing and me not getting something better to them sooner, or us as an industry. And that applies not just to me. Obviously, you asked me directly, so I'm being selfish. But to me, every time I see issues in society that are related to poor performing batteries, it's a motivator to hustle, because we've gotten used to the battery. The battery is fantastic. It's gotten us to where we are, but by golly, can it be better? And so that's really the headline that scares me the most, if I can be honest, and why we do what we do.
Making batteries safer for everybody. I
That's
love
right.
it.
And look, as the team always reminds me, good batteries are boring. And
Yes.
that's true, right? You don't even
Yeah.
want to think about it, right? So
Yeah.
it's kind of a pretty humble industry to be in. It's like, well, I've got the best battery. Why? Because nobody talks about it. Like it's inherently safe. Everybody, it's a pretty powerful statement.
That's funny. It's like when you'll know you succeeded when people are bored about talking about batteries because
That's right.
they just work.
Exactly. It's like turning on the light, right?
Yeah.
It works, right? You don't have to worry about it. So that's the idea.
That was my last question I had for you. Is there anything we haven't touched on that you'd want to touch on?
Every time I get the opportunity, it's an invitation for the market to get excited about batteries. We are in a place where yes, there has been some very powerful lessons for the industry. Everybody has learned, investors have learned, battery companies have learned. It's an opportunity for us to re-engage at a very different level, because we have to realize that where we are going as a society is going to demand better batteries. So we have to see it with excitement again. Like I said, we've learned a lot. And I think the industry is ripe for a new framing of why it exists and what it needs to deliver. And so we need to continue to hold each other accountable, of course, but just an opportunity to remind everyone that these things are important. They're ubiquitous and they're boring, but they're very important. It is certainly a space that is challenging, and the challenges, though, I firmly believe, are only making us stronger because the burden of proof is higher. That bar that you have to get to actually prove your technology is higher. And that's only going to make better batteries. And so it's an invitation for, pun intended, re-energize the market to get us to an optimistic view that the light is at the end of the tunnel. And what we hope to deliver in the next year is certainly proof of that. So.
I love that pun, as well as I'm going to keep my eye on your company.
Love it. Excellent. And you're going to keep this eye? No, this one. Keep the good one. Okay.
I really appreciate your time talking to me today. It's been fantastic. Thank you so much.
Thank you, Matt. Really appreciate it. Take good care. Bye-bye.
So once again, my thanks to Jorge for joining me. But what did you think about this one? Jump into the comments with any questions, anything you want to follow up on from the conversation, or where do you even land on this whole, is it really solid state or not debate? I'd love to hear what you have to say. As always, jumping into the comments, liking, subscribing, and sharing with your friends are all easy, free ways to support us. But if you'd like to support us more directly, you can go to stilltbd.fm or click the join button on YouTube. Thank you so much, everybody, for taking the time to watch or listen, and we'll talk to you next time.